Hello friends, welcome back to Compiler Hacking. As usual, we are working on Natalie, our Ruby compiler, and this video is going to be pretty fun, I think. I hope you'll stick around for it. I'll give you the short explanation and then I'll dive in a little bit deeper. Basically, I want to add compile time macros, user-defined macros to Natalie that operate on the AST, abstract syntax tree, at compile time, a little bit like a Lisp macro perhaps, and that would let us do some pretty cool stuff. Let me now give you like the longer explanation. Here's a perfect example. This is a script called runner.rb. It's in our test directory, and the way that you run it is, actually I can just copy this right here. That would be perfect. The way it works is, while that's running, it is spawning out for every path that is given. It's spawning out to Natalie. And so here it ran the first A spec, and then you saw they ran the B spec. And so it's a little bit hokey that we're having to spawn out right here. Wouldn't it be cool if we could do each do path like so, require path, and just not have any of this stuff? Well, that would be nice. But it doesn't work because the way we do require with Natalie is at compile time. Without getting too into the weeds, we can't do runtime require because that would necessitate us having a compiler that when we load up that file, we have to compile that into C++ and then run that through GCC or Clang, and we produce an object file. We don't have that at runtime. Now, that's not to say that we couldn't do that. I've actually thought about doing that, but we don't need that in a lot of cases. We could make a macro to achieve some of the same results. So what I'd love to do is just invent a new syntax here and then go implement it. So you get to see my brain at work. Require, I guess, Natalie macros. I want to have to require something to enable it. We do this with inline C, C++ as well. So we have this inline thing, but I want to make a new one called macros. And then I guess I'll just have a macro bang call, require argv is what I'll call this macro. And then inside of here, I'll have a block. And so the macro will be defined inside the block. And let's test this out on the command line first. Natalie e print argv map path, and then I want it to produce the same nodes that our abstract syntax tree produces, and I can kind of show you what that looks like here. Let's see, AST. So this will show you what our abstract syntax tree looks like. It's these are essentially arrays of various symbols and values and things. And so we want to produce the same thing where you have path, and then we're going to create an S expression that's going to call the receiver being a nil and the message being require, and the argument being a string. You have to create strings like this in the AST, and then the variable path, and close that, and let's run that. Let's give it some arguments. So that didn't work because, why didn't that work? Undefined method S for main. Okay, I need to pass the -i flag here so that it runs through our new compiler. I'll get into that a little bit more later. But so we have two S expressions here, one for the first file and then one for the second file. I need to wrap this whole thing in an S expression, which shouldn't be too hard. If I do S block and then splat or spread that out, and then put some parens here, and that should look right. So we have our block, and we have the two require calls inside of there, and so that's the sort of thing we want to produce from our macro. So let's just kind of do this like so, and argv map path call path. I think that's right. Might be kind of nice to pull this out a little bit. So we do requires equals this. Just clean this up a little bit. And something like that. So that's the macro I want to create. And then down here to use the macro, I would do require argv. It'd be really cool if I could pass in, you know, the parameters, but I think this is good because we could call it require many argv. So that'd be another way to do it. But I think for now, this is the simplest. I don't have to mess with arguments. This is the simplest possible thing that can work. Cool. Now let's see it fail. Runner, and I happen to know I'm going to need a // on this. So let's just go ahead and do that. Cannot load such file Natalie macros. Okay, well, let's go work on that. In our compiler.rb inline right. Oh, I'm already there. Right here. We're just going to do basically the same thing, macros enabled, where we intercept the require, and it's not a real require. We're not actually going to load a file. We're just going to set a flag and return an empty block of code. Macros enabled, CPP enabled. So let's just put the same flag everywhere. Macros enabled. Okay, so we have it all the same places. Cool. So let's run this again. And undefined method macro bang. Cool. So macro expand macros does a thing where we check and to see if it's a macro call, and then we call run macro, and run macro calls method macro underscore something. Okay, I said the word macro a lot, but I guess we will just add, are these in some sort of order? Nope. Macro bang, and then def macro bang expr and current path. I think that's how we do it, and we're just going to print the expr and exit. So let's see if that even works. It does. Do I want to I think I don't want this to do anything if it's not enabled. So let's do macros include macro. I don't want to intercept it if, so I don't want it there. Like to do else if, no. Let's do it this way. If it's one of these built-in macros, then return the name. Else if macros enabled and the name is macro, then return the name. So that way it only works if macros are enabled. Cool. So nothing should have changed here. And so this is what we get back. Let's just copy paste that and paste it right here. So it's going to look something like this. So we have an iter, which is how a block is passed in Ruby, or in Natalie, I should say. And then the call, which is our macro, a call to macro. So we get the name here, and then a 0. Let me just make sure these parens, yep, those match up. And then this is the block, and that goes all the way to the end. Cool. Cool, cool, cool. So we want to ignore the first part, which is an iter. And then the call is here, and then 0. What does 0 do? I don't remember what 0 is for, but we're going to skip it. It might be arity of the block, possibly. Yeah, we'll skip it for now. And then we'll just say block here. So expr, and we want to store the macro somewhere. Where are we going to store it? Let's store it in a macros hash. So macros, oh, I need the name. So I need to destructure this call, which is like this. So it's going to be something ignored, something ignored, something ignored. Maybe I should just do name is call.last. And ignore the lit part. So the name, I just want this little symbol right here, so require argv. So that's the name, and then we'll just do name is block. And then we're going to return an empty block of code. Cool, cool, cool. So we're not exiting anymore. So now, perfect. Undefined method, require argv for main. Great. Now I need to say if name is macro name, else if macros key, let's see, macro is macros, let's look it up by name. Let's print it and then let's exit just to make sure we're on the right track. Perfect. So now we got our block of code here. And now here's where the magic comes in. We've been working on a new compiler, a brand new compiler I've affectionately named Compiler 2. I have a video about that. I can't remember how much detail I went into, but I've been working on it for the past month. And the cool thing about Compiler 2 is it has two backends. It has a CPP backend, which compiles to C++, and this is very much like our existing Natalie compiler. And so eventually this will replace the existing Compiler 1. We'll replace it with Compiler 2. But it also has another backend, or I don't know if it's really a backend, but it's called the VM. And so it is an interpreter VM. It just walks the intermediate representation and interprets it directly and brings back the result. I can kind of show you the bits and pieces of it like this. If I say bin Natalie let's print hello world. Like this, obviously it's going to print hello world. And the old compiler, if I do a debug of pass 1, I'll show you what pass 1 looks like. It's just AST. And if I do pass 2, then it's slightly different AST with a few more things sprinkled in. Pass 3 is mostly the same, almost nothing. I think nothing changed. And then pass 4, does it even do that? I don't remember. I think it'll show you the C++ that's generated. So that's the old compiler. What it does is it manipulates the AST step by step until we get C++ code. The very last pass of the compiler takes that AST and writes C++ from it. So the new compiler, if I pass C2 and I do debug of pass 1, you're going to see something completely different. There is no more AST. The very first step of our new compiler produces an intermediate representation that sort of assumes it's going to be given to a stack-based VM. And that's exactly what our VM is a stack-based VM. It doesn't have registers. It has a stack that it can push and pop from. But our C++ backend interprets these instructions and converts them or compiles them to C++. It's pretty cool. So if I show you pass 1, looks like that. Pass 2 looks like this. It just adds a little bit of scoping information. So if I had a variable, hi, and I printed X, then you'd see that I have variables and it marks which ones are mine in my scope. Let's go back to this one. So that's pass 2, pass 3. I honestly don't remember what pass 3 does. Let's see, pass 3. Breakpoints for breaks from blocks. Okay, so if you call break in a block or a lambda or a while loop, then this pass handles all that. So that's why we wouldn't see anything here. Anyway, it still produces this same or very similar C++, but what I can do is pass I for interpret, and that's what you saw earlier. I was passing -I, and it just interprets the instructions directly. Whew. I don't know if that made sense. I hope it made sense. But that's what we're going to use for our macro handling. Back up here, we had test runner. We're going to pass this into the VM to run at compile time, get the result, and then put it back into the AST and keep going. How do we do that? I don't know yet. We're going to give it a try. So if I have this macro here, and let's say I run, let's see, I don't remember what I called it, compile and run. So I could just do VM compile and run macro. New AST. So that should produce, is that right? Am I thinking that right? So this AST from here will be interpreted and produce new AST. Yes. And then do we just return it? Yeah, but I think we call expand macros on it. That way, one macro could return an AST that calls another macro. So we want to do expand macros, new AST, compile and run, vmrb, compile and run AST. Does it not have a path? I guess I didn't pass in a path. That's okay. New AST macro. So maybe I should call this path. Let's see, path. Call this macro. That way, if there's a backtrace, then we'll see the word macro and kind of know maybe what we're talking about. So I know I forgot something, but we're just going to try it. Given to expected one, required keyword path, VM120, compiler RB 301. 301. Oh, path. Wrong number of arguments. 302, given one, expected two. Expand macros. How do you work? Oh, it also has a path. Which is what? Where else are you called? Expand macros. Expand macros. Oh, this is just the question if it's a macro. Okay, silly me. That's not where I want to do that. Name. Okay. I want the name here to be user macro. Okay, def macro, user macro, expr current path. This seems more like what I need. Let's print the expr and exit. So let's make sure that this kind of works. Missing keyword, current path. Let's try with an R. Call nil, require argv. Cool. So this isn't how that works. I'll say key. So if it has a key of that, then great. And the way that works is nothing, name. Okay, nothing, name is expert name. Macro is macro's name. And this is path, current path. Okay. Does it work? Something's happening. It would have errored already. Cool. 71. Yes. And if I run this with Ruby, do I get the same results? Natalie macros. I can't do that. Yeah, that's okay. So, that's pretty cool. Runner RB. Was it really that easy? So let's do the old one, put that back. Let's comment this out and let's time the old one and then time the new one and see what the difference is. This was what I was really excited about, was getting rid of a bunch of overhead of the compiler. I don't know how much, but I guess we'll find out. So 40 and 31, it would be 71. So we know that adds up. That's pretty cool. And then let's go put this back and run it again. And so that first one took 13 seconds. And this one took 8 seconds. That is awesome. That is awesome. So, oh man, the nat binary thing. I don't know. Okay, so let's see if we can put this back. Requires each requires I don't know if all of this will work in the new interpreter, but I'll put it in here just to see. So we need a directory. Let's just give it the spec directory. Didn't like that. Private method puts call for nil class. Oh yeah, because I don't have stood error set up. Okay, fine. Let's do this. Fix me. Use stood error dot puts. Okay, let's put that there. So let's try it this way. Skipping directory spec. Perfect. You know, actually, I think I could just fix this. That wouldn't be too hard. If I go to the VM RB and I set stood error to stood error, it's just going to be mapped directly to the same one. Stood out stood error. Does that work? Yeah, that works great. Well, that was much easier. Is there anything else that this does? So it does use nat binary. Where do we use that? I don't think I use that anywhere, so I'm just going to get rid of all this. What are you complaining about? Oh, use warn. Okay. Do we have warn? I don't remember if we have warn or not. Yes, we do. Yes, we do. So I know 8, almost 9 seconds isn't spectacular, but it's a whole lot better than 13 seconds. And I assume that the more of these we do, let's do array test. And let's just do, how many A stars are there? Is there a letter? There's D, there's 4 Ds. Oh, that's cool. You can't see that. There's 4 of them. I'll scroll up. There we go. Okay, that ran in 11 seconds. And the old code, get show master test runner.rb test old runner.rb. So if I did this with the old runner, what would that take? Okay, so 20 seconds versus 11 seconds. So pretty significant. And the more files you have, the more dramatic that's going to be. And if I were to compile this, just to prove that I'm pretty sure most of this is in the compilation, it's not actually in the runtime, which makes me hopeful for the future. It means that we can probably optimize the compiler and get a whole bunch out of it. So it took 11 seconds, 11.1 seconds to compile the code. And if I just do /r, then that was really fast. So it takes 0.03 seconds to actually run it. So it's just that our compiler's slow. No biggie, right? It's written in Ruby. So what can I say? There's a lot of work that can be done to make that faster. And we'll get there. We'll get there. So let's just let's admire our work. We have to require this for it to work. Let me just verify that is true. Here, that should error, right? Yes, undefined method macro for main. And if I put this back, then it works. So this is how you define a macro. We didn't do macro arguments, so maybe in a future commit, I'll work on, so you could say our, paths here. We'd rename this to require many arg v, and then paths. That might be fun. I'm not going to do it in this video though. I'm going to leave this. I want to leave well enough alone. This works and I'm happy with it. And we'll do test, remove that. And let's commit it. So we have the macros hash. We have the Boolean of whether it's enabled. We have this logic to see if it's enabled and there's a macro with that name, then cool. This code can go away. User macro. I'm not sure how I feel about macro. That can go away. Boom. User macro. If, yep, that's how we set the Boolean. We did fix this. We should probably make that a separate commit. Nope. Add, let's do VM add stood out and stood error globals. Okay, all of this file and all of that file, and we'll do that as a separate commit. Why not? Let's get as many commits out of this as possible. Add user defined macros. Just as simple as that. Rewrite test runner.rb to use macros. I'll say use a macro. Oh, that's cool. I hope you like that. That was a lot of fun. I'm not sure if it made a ton of sense, but this is one of the things I've been wanting to do with the interpreter for a while, is be able to do things at compile time with the interpreter and not have to fire up another compiler and the GCC and Clang and all the machinery that goes along with that. There's some overhead there, obviously. I wonder what other cool things this will enable. What can we do with macros that we didn't have before? So something to think about. I hope you enjoyed the video. I hope you come back for more. I'm going to try to be doing more videos. I say this every time. Life gets in the way sometimes. But hope to see you very soon in another video. I'll talk to you later.